Question number 3. Question number 3 says, a circle with center 1 minus 1 passes through the point 4, 3. And it says, determine the radius of the circle. Now, anytime I'm doing these questions, I love to just draw something so you can see what I go on. So what I mean is I want you to draw a circle and just label the center as 1 minus 1. Label the center 1 minus 1. So this is the center, all right? And then another point on the circle is 4, 3. So let's say 4, 3 is A, is right here. Call the point A, all right? So let's say this is 4, 3, all right? So if this is the point 4, 3, all right, then they want the radius. So isn't the radius just this distance, the distance from the point on the circle to the center? Yeah, man, that's the radius. So the radius R is going to be equal to the length of the line. To find the length of the line, it is just the square root of x1 or x2 minus x1. So it's 4 minus 1 square plus y2 minus y1, which is 3 minus 1 square. So this is what we're working out now. And what we're getting is 4 minus 1, and then we square that plus 3 minus 1 square. That's square root of 25, which is 5. So the radius is 5 units. That's the radius. Now it goes further to say, write the equation of the circle in the general form. All right, not in the standard form, but in the general form. Now, to write the equation of the circle in the general form, we can start by writing it in standard form first, because we know that the circle is going to be x minus a, where a is the x coordinate at the center, and so that is x minus 1 all square plus y minus 1, which becomes y plus 1 all square, and it's equal to r square, which is 25. And all we need to do is put it in the general form. To put it in the general form, we get it out of the standard form. So we need to expand the bracket to write this as x squared minus 2x minus 1 plus y squared plus 2y squared plus 2y plus 1 is equal to 25. This is when we expand it out. So we have no issues now. We have no issues whatsoever. Now we can put it in the form that it should be in by writing it as x squared plus y squared. And then now we're going to write it as minus 2x plus 2y. It should be plus 1. Now 1 plus 1 is 2, and bring over to 25. 2 minus 25. 2 minus 25 is minus 23. And that's equal to 0. Nice and easy. And that's it. That's it. That's it. Nice and easy. Soft. All right. Now the next question, it says determine the equation of the tangent at the point 4, 3. So we want to find the equation of the tangent. All right. So if this is 1 minus 1, I just like to get a schematic of it. When I have a schematic, right, So if I were to draw a schematic, I'm just putting in the X and the Y axis so we can see what really is taking place. Let's say this is the circle. This is the X and the Y axis. All right, I'm just giving you a schematic of what's going on. Getting a schematic of what's going on give you an idea of how your tangent really is. So as you can see, if we want the tangent at this point, right? Let's say you want the tangent at that point, 4, 3. This is how the tangents look in reality, all right? So as you can see, it passes through some positive y value, all right? This is going to be the tangent, all right? So the tangent has a negative gradient and it passes through the y-axis here, all right? So my speculation is that we're going to get something like maybe 3 or 4 as the y-axis intersect. All right, so let's go ahead and find the equation of the tangent. That's like when we get a sketch, and this is the line that we're gonna find. We're gonna find the equation of this line. All right, so I'll call it L. Should I call it T, but no worries. So first thing, before we can find the equation of the tangent, we need the gradient of the tangent. But the gradient of the tangent is equal to -1 over the gradient of the normal. So first we have to find the gradient of the normal. Now remember the center is 1 minus 1 and the point is 4, 3. So the gradient of the normal is going to be y2 minus y1. So it's 3 minus minus 1 over x2, which is 4 minus x1. So this is going to give us the gradient of the normal. So the gradient of the normal is 3 minus minus 1, which is 4. And so that is 4 over 4 minus 1 is 3. And so if the gradient of the normal is 4 over 3, then the gradient of the tangent is minus 3 over 4. This is then the gradient of the tangent. So then the equation of the tangent, I'm going to write EQ for equation. So the equation of the tangent is going to be given by y minus yp, which is y minus 3, is equal to the gradient of the tangent, which is minus 3 over 4 times x minus 4. You can simplify it if you want, but I'm going to stop right here. The question didn't ask me to put it in standard form, so I'm going to stop right there. So this is the equation of the tangent. You can go further if you want. It really doesn't matter. Then part B. Part B says two vectors P and Q are such that P is 8, 2, Q is 1 minus 4. Find dot product of P dot Q. All right. Now P dot Q is going to be equal to, it's going to be 8 times 1, multiply our I components, and then add it to the sum of the product of our J components, which is plus 2 times minus 4. Now 8 times 1 is 8, plus 2 times minus 4, the dot product is 0. Now since P dot Q equal to 0, then the angle between the two vectors is 90 degrees. All right. So the angle is 90 degrees since P dot Q is equal to 0. So the angle is 90 degrees. We can just tell them that there's no calculation to show. It says state the degrees of the angle. Nice. It says now the position vector A is 4i minus 7j. Find the unit vector of A. So you have to just remember that unit vector A is equal to 1 over the magnitude of vector A. It's 1 over the magnitude of vector A times vector A. That's unit vector. So we need to find the magnitude of vector A. Let's find the magnitude of vector A up here. The magnitude of vector A is equal to 4 squared plus 7 squared all square rooted. That's the magnitude of vector A. Now 4 square is 16 plus 7 square all square rooted. So we have 4 square plus 7 square, which is 65. So the magnitude of vector A is the square root of 65. That's the magnitude of vector A, the square root of 65. Nice and easy. All right, so this is 1 over the square root of 65 multiplied by vector A. And vector A is, of course, 4i minus 7j. And so this is the unit vector. If you want, you can go further, and some people like to write it as 4 over the square root of 65 times I. Nothing is wrong if you put it like this either. 4 over the square root of 65 minus 7 over the square root of 65 j. Nothing wrong if you put it like this either. Nice and easy, soft. Okay, that takes care of question 3. Now we go to question 4. Question 4 generally want to deal with like trigonometry, because question 3 deal with coordinate geometry and coordinate geometry as well as vectors. In question 4 deal with strictly trigonometry. All right, so it says a compass is used to draw a sector with radius 6 and area 11.32 centimeters square. So this is what they normally have, a sector. I know my sector don't look good at all, but then you will say the length of the radius is 6, and they tell us this area is 11.32, and then this is the angle. The angle is right here, theta. Then it says determine the area, determine the angle of the sector. This angle theta, we need to find it. Now, first and foremost, area of sector. Write down area of sector formula. Area of sector formula is equal to theta over 360, which is 2 pi. It's theta over 2 pi times pi r squared. That's how we find area of sector. All right. This is how we find area of sector. This pi will cancel this pi, and so it is really a half r squared theta. That's really the area of the sector. So the area of the sector is going to be 11.32. That's what they said. And so 11.32 is equal to a half r squared. R squared is 6 squared times theta. And so all you need to do is transpose to find theta. So a half r squared, which is a half 6 squared, which is 18. We divide by 18 to get that theta is 11.32. Theta is going to be 11.32 over 18. That's theta in radians. All right. So 11.32 divided by 18 is 0.628. This is 0.628 or 0.629 radians. I'm going to write rads for radians. And you're done this one. Then they say further find the perimeter of the sector. The perimeter of the sector, to find it, it's going to be this length 6 plus this other length 6 plus the length of the sector. That's how we find perimeter. All right. And so the perimeter is equal to 2r plus the length of the sector. And the length of the sector is given as r times theta. That's how we find perimeter of a sector. So it's going to be 2 times r. R is 6. So 2 times r is 12 plus r times theta. R times theta is 6 times 0.629. So whatever is 6 times 0.629. So all you need to do is go ahead and put that in a calculator and tell me what you get. So you get 12 plus 6 times 0.629. And so we get 15.774. So that's what we get. We get this is going to work out to be 15.774. And perimeter is always in centimeters. Nice and easy, soft. That's what we get. After we work that out now, then we have this right here. It says a right angle triangle X, Y, Z as angle theta, where the sine of theta is √5/5. Without evaluating theta, calculate the exact value. Insert form, if applicable, of cos theta. Now, let's just go back to trig ratios. Like if I draw a triangle right up here, so, right? And I put some angle upon the triangle, call it theta. So what it'll tell me is sine theta is √5/5. So the opposite is √5. And it'll tell me, say, the hypotenuse is 5. So just need to find the adjacent. What's going to be the adjacent? The adjacent is, so we need to find this length adjacent. So the adjacent is going to be 5 square minus √5 all square, which is 5 square rooted. I'm getting the square root of 20. All right, so the adjacent down here, so let's call it A. Adjacent down this have to be the square root of 20. Because remember, adjacent square plus opposite square must equal hypotenuse square. Nice. Yep. So we have the square root of 20, the square root of 20 square, plus the square root of 5 square. That give you the hypotenuse. Nice. So now we can find cos theta. So cos theta is equal to adjacent over hypotenuse. Right, so you can just write that down for them, that cos theta is adjacent over the hypotenuse. And adjacent is the square root of 20 over the hypotenuse of 5. That's the square root of 20 over 5. Then it wants sine 2 theta. Sine 2 theta, we have to remember double angle formulae. Sine 2 theta is 2 sine theta cos theta. That's how we find sine 2 theta. Sine 2 theta is 2 sine theta cos theta. So now we can go ahead and say, all right, go punch in whatever is sine theta. Sine theta, √5/5. So this works out to be 2 times √5/5 times cos theta. 2 times √5/5 times cos theta. And we know that cos theta is going to be √20/5. All right. And this will give us whatever is sine 2 theta. So √5 times √20 is √100. √100 times 2 is 2. So this is √100. So this works out to be 2 times √100 over 5 times 5. 5 times 5 is 25. I would want to leave my answer like this. I think I can simplify it. Square root of 100 is 10. And so 10, square root of 100 is 10. Yeah. And 10 times 2 is 20. So I can leave it as 20 over 25. I'll leave it like this, 20 over 25. Don't want to simplify no more. That's that. Now part C. Part C, the easiest part, it says show that tan squared plus 1 is equal to Show tan squared plus 1 is equal to 1 over cos squared theta. Now, there are many ways to do this. All right, tan squared theta plus 1. There are many ways, but let's just do it. So we'll start with our left-hand side. The left-hand side is just tan squared theta plus 1. All right, tan squared theta plus 1. All right, so this is what we have. All right, now we have that tan squared theta plus 1. What we can do then is we can change tan square to sine square over cos square. So we can say this is going to become sine square theta over cos square theta. That is tan square theta. Tan square theta is sine square theta over cos square theta plus 1. Now this plus 1, we can rewrite plus 1 as cos square theta over cos square theta. Let's do that. We can rewrite 1 as cos square theta over cos square theta. Anything divided by itself is 1, except 0, of course. 0 over 0 is indeterminate. So cos square theta over cos square theta, that's what we get. And so now, when the denominators are the same, all we can do is just add the numerators. So adding the numerators, we're going to just get sine square theta plus cos square theta over cos square theta. So we have sine square theta plus cos square theta over cos square theta. Nice and easy. Now, sine square theta plus cos square theta, that's equal to 1. So we get 1 over cos square theta. That's what we're getting, 1 over cos square theta. See it there? And we get our right hand side. Nice and easy, soft. Now, of course, we could have done this by other means. We could have done it in 2 steps by saying tan square theta plus 1 is sec square theta, and sec square theta is 1 over cos square theta. All right, but that's for a different day. Another day we do it another approach. Another day we could have started by sine square plus cos square is 1. Divide through both sides by cos square. Then we're going to get tan square plus 1 is 1 over cos square. So there are many means in which you can get your answer, but this is the approach we chose today. Another day, another approach. Easy, soft. That takes care of question 4. Now, we go ahead now to question 5. Skip the page. All right, finally, question.